Hi, and welcome to today's teaching. I'll be taking us through the Microsoft Azure Data Fundamentals. In a minute, I will just be introducing myself briefly. My name is Praise Oguna. I'm a cloud data evangelist. I help organizations, businesses to modernize their data in the cloud. I am a data engineer with over 3 years of experience in data-driven business transformation. I have leveraged my skills and expertise in various data engineering projects. I will help businesses reduce cost, improve revenue, optimize processes, and cater for customers' unique needs. I've made use of Azure Synapse, Azure Data Factory, the SQL, Azure. Also, just performing my daily tasks. I also make use of Python and so much more. So that's about me. Nothing big, just about me. Briefly, just like you've met me, I would also like to meet you. So I would like you to drop this in the comment section. Like to drop your name, your company of affiliation if you're working. If you're not, that's also fine. Also your job roles, your responsibilities that you undergo every day. Also your business intelligence experiences, and very importantly, I also like to know your expectations for the course. So just very quickly, we'll just dive right into it. We'll be looking at module one for today. So the course is going to be divided into modules and modules divided into lessons. So for today, we're looking at module one. We're looking at the core data concepts. So under module one, we'll be learning the following concepts. We'll talk about what data is, types of data, data storage, relational data, non-relational data. Talk about classification of data, structured, semi-structured, unstructured. How is data defined, stored, assessed in cloud computing. Under that, we're talking about analytical systems, transactional systems. We'll also go further to talk about roles and responsibilities of data professionals. We'll also talk about the common database tools that these professionals use to perform their day-to-day tasks and responsibilities. So down to lesson one, we'll talk about, just like I mentioned, we're talking about the core data concepts. Just these are just an overview of what I just mentioned before the slide. We're talking about data, types of data, classification of data, how data is defined, stored, accessed in the cloud, roles and responsibilities of data professionals, tasks and responsibilities, and then we'll talk about the common database tools. So at the end of this lesson, you'll be able to identify how data is being stored, identify characteristics of relational and non-relational data. You'll also be able to describe and differentiate data workloads, explore data job roles, also be able to explore common tasks, tools for data job roles, explore the characteristics of relational data, explore relational data workloads offering in Azure, and so forth. Also be able to describe types of non-relational data, also be able to talk about, describe non SQL and types of non-relational databases. So let's just dive right into it. So what is data? Data is more like what we use on the daily basis. So businesses use this to make informed decision. Data is everywhere. Everything we do right now, it's data. You run on the internet, you're dropping your data one way or the other. So your data is being collected on a daily basis. So data is a collection of facts such as numbers, descriptions, observations, used in decision making. So the main purpose of data collecting or having data is to make informed decisions, right? Right. So we can classify data as relational. Under relational, we also have structured. Under non-relational, we have semi-structured and unstructured. Data can be classified into relational data, which is structured, non-relational data, which is semi-structured, or unstructured. So when you talk about what is structured data, so what are the characteristics of a structured data? Let's talk about data like let's see it this way. So just for us to have an analogy and for us to paint a picture in our minds what a structured data could be. So let's think about structured data like a neatly organized filing cabinet. So imagine you have a spreadsheet with rows and columns, right? So each rows represents a person and each column has a specific information like a name, age, and addresses. Everything is orderly and easy to search. It is the kind of data you find in databases. For example, a list of students with columns for their names, their ages, and their grades. We have a different table for products with columns like for product name, price, stock quantity, and all of that. So everything is more organized neatly. So it has a predefined schema. Body that is in tabular form. It contains number of rows and columns. All rows in the same table have the same set of columns, right? So it's everything in relational data is quite organized and in a structured manner. So when it comes to semi-structured, yeah, let's look at it as like a messy desk. Let's just have a paint a picture in our mind so we can understand that better. It's more like a messy desk with piles of papers. The papers have some kind of organization, not totally organized, but some kind of organization, but not in a strict format, right? But not in a street format. So let's think about emails, for instance. Let's think about emails, the HTML web pages. They have some tags and markers to help identify bits of information, right? But the structure is not as rigid as a spreadsheet. We can all agree to that. So emails, so like for example, we have emails. So each email has a sender, has a recipient, has dates, has messages, but the format can vary. Emails formats can vary. They don't have a predefined format. So email formats can vary from one to another. We also have the JSON, right? JSON files. These have tags to define data elements, but allows for some kind of flexibility in the structure, right? So it's structured in some kind of way, but not organized like the structured data. So when it comes to unstructured, let's think of a big random stuff, right? A big random box of stuff filled in it. It contains valuable information, but there is no specific order, right? But um, there's a specific order or easy way to categorize it. So this includes things like text documents, videos, social media posts. It's not organized in a predefined way, making it harder to analyze and search. For example, a collection of photos talk about video recordings of meetings, free-form text like tweets or personal notes. So just in summary, structured data refers to neatly organized data, just like a spreadsheet. Semi-structured data has some form of organization like emails or web pages. Then when it comes to unstructured data, no specific order, more like a random collection of photos, videos, and all of that, right? So that's that for how data is being classified. So these are examples of structured data or relational databases. We have the SQL Server, we have the Postgres SQL, we have the Oracle DB, we have the DB2, which is also popular, and we have the MySQL Server. So when it comes to characteristics of a relational database, when we talk about characteristics, we talk about when you see a relational database, what are the forms it takes, what are the things that you see, and you know that this database is. relational database. Let's talk about the characteristics. So we'll talk about them in this format. So we'll talk about the characteristics. We have the atomicity, we have consistency, we have isolation, and we have durability. So atomicity guarantees that each transaction is treated as a single unit which either succeeds completely or fails completely. So if any of the statements in a transaction fails to complete, the entire transaction fails and databases are left unchanged, right? Just to break down what atomicity means. Just imagine you're transferring money from your friend, right? Imagine you're sorry about that. So imagine you're transferring money. Imagine you're transferring money from your friend from point A to point B. You're transferring $10,000, pounds, euros, whatever denomination you're transferring from. It doesn't really matter. The point I'm trying to make, we're transferring money, right? So you're transferring money to a particular friend. So it's either that money you transfers goes completely or fails completely. You can't be transferring $10,000 to a friend and your friend ends up getting $5,000. In relational databases, it doesn't work that way. It's either the whole change is made to that account by adding that $10,000 to that account, or no change is made at all. So either the $10,000 goes to your friend's account or it doesn't. So atomicity guarantees that each transaction is treated as a single unit, not half goes or half doesn't or half fails, right? So either it succeeds completely or it fails completely. So that's what atomicity is saying. So when it comes to consistency, consistency ensures that a transaction can only take the data in the database from one valid state to another. So this is like a rule checker, right? When it comes to consistency is like a rule checker. It ensures that only valid changes are made to your data. For example, if you try to withdraw money, right? If you try to withdraw more money than what's in your account, consistency will prevent this transaction and keep your account balance intact. You can't withdraw what is not there. You can't change what is not there. You can't make change to the database. So consistency is more like a rule checker. It ensures that everything is done the way it should be. So it ensures that only valid changes are made. You can't make changes that are so invalid when it comes to relational databases. Isolation ensures that your concurrent execution of transaction leaves your database in the same state that it would have been obtained if the transaction were executed sequentially, right? So when it comes to isolation, imagine that your siblings are sharing a candy box. Isolation ensures that if you both reach out for a candy in the same time, you don't end up grabbing the same one. So in database terms, it ensures that transactions are processed independently and are securely without interference, right? Isolation ensures that transactions are processed independently and securely without any interference. When it comes to durability guarantees that once a transaction is committed, it remains committed even if there is a system failure such as power outage or crashes. So once the transaction is completed, durability ensures that it's permanent even in the event of power loss, crashes, errors. It's just like once you have transferred money to a friend, the transaction cannot be undone, right? So it ensures that transaction has been committed, it remains committed even if there is a system failure such as power outage or kind of any crash. So when it comes to characteristics of a non-relational database, we have it allows storage of data in a flexible way. Two entities in the same collection can have different sets of fields. It lacks a fixed schema. Because it lacks a fixed schema, that means it allows storage of data in a flexible way. Data can be stored in different patterns and different ways. How is data defined, stored and accessed in cloud computing? So depending on the type of data, such as structured, semi-structured, or unstructured data, data can be stored differently, right? Structured data is typically stored in relational database such as the SQL Server, your SQL, Azure SQL database, your MySQL, and so forth. So Azure SQL database is a server that runs in the cloud. The act of setting up a database server is called provisioning. We'll look at that in coming modules and lessons. When we talk about the SQL Server, we talk about the Azure SQL database and so forth. So data can be stored differently depending on the type of data, either structured, semi-structured, or unstructured. They all have their databases, they all have their servers that they can be stored differently and properly, right? So data processing solutions. So data processing solutions often fall into two broad categories. When we talk about data processing solutions, we talk about the analytical systems and we talk about international processing systems. So when we talk about transactional systems are like the cash registers at a supermarket. They handle everyday transactions and keep track of each sale, return or exchange as it happens. Used in the day-to-day running of a business. Transactional system is often what most people consider the primary function of business computing, right? That system is more like a day-to-day, it's used in day-to-day running of a particular business. I just like I explained earlier, transactional system is like the cash registers that we use in supermarkets. They handle every transactions and keep track of each sale or return or exchange, right, as it happens. So one of the key points to note when it comes to transactional system of processing is our real-time processing. So transactions are processed immediately. For example, when you buy groceries, the cash register updates the inventory right away. So data is being taken at as we go, like more like taking data on the go and being processed immediately, almost immediately. So and they can also take in high volume data, right? High volume data. So they handle a lot of transactions every day. Think of customers checking out at a busy store, right? Every transaction is being processed fast and it processes a high volume of data, right? I just mentioned two things. One of the characteristics that you used to know, international system of processing, it has real-time processing, it processes high volume data, and third is accuracy. They ensure that every transaction is recorded accurately to keep track of every inventory and finances, right? First, real-time processing, we have the high volume and we also have accuracy. Let's take for example at a bank, when you deposit your money or withdraw cash from an ATM, the system records these transactions instantly. Let's talk about the online shopping platforms, record each purchase and update their inventories and process payments immediately. So transactional systems, it's more like a primary function of business computing. So it updates records on the go. Once payments are made, once customer makes purchases, records are being updated. So it's the business owner uses that to make decisions on the go, right? So that's it for transactional system processing. When it comes to analytical system of processing, they so analytical systems, they are I refer to them as the detective agencies for businesses. So they take all the transactions, data collected by the systems and then analyze it to find patterns, trends, insights that can help make better decisions, right? So some of the key points to take when it to look out for when it comes to analytical systems is data analysis. So this system look at large amount of data over time to find useful information. For example, they can identify which products they can that are selling best and when these products are selling, right? So a business owner can look at the product and say, these products are selling best in December. So we'll buy more products, these products in December. You can say, oh, this particular product is selling more when rain falls, or this particular product sells more when the sun shines, or a particular set of people are buying this product. We have the young person buying this product more. We have older people buying this product more. So they use that. Data analysis is one of the key points to note when it comes to analytical system processing. So another point to note is decision support. They help businesses make informed decisions. For example, they can suggest how much stock to order based on the past sales trends, right? So just like what I've mentioned, they help businesses to make decisions and all of that. So also complex queries, they can answer complicated questions like which products are most popular among teenagers in the summer and so forth and so they help business owners answer questions by solving complex queries and help businesses make informed decisions. So in summary, transactional systems is like a supermarket cash register, handling daily transactions and keeping your accurate records in real time. Analytical system is like a detective agency, examining all the collected data to uncover patterns, insights to help businesses make informed decisions. By understanding these systems, you can see how businesses manage everyday operations and use data to plan for the future. So these are the analytical system processes when it comes to data ingestion. Data is being ingested from um, different sources. The tools that they use to take in data, whether it be the systems, the computers, whatever they have to gather data from customers. For instance, when it comes to businesses and all of that, so data is ingested into the processes into the system, and then some of these data might come from separate OLTP systems. To process and analyze this data, you must first store the data in a repository. Right, so data is being ingested and stored in a database, right? It can be a relational database and a non-relational database, but the point is data is being ingested and then stored in a database. So when it comes to after that, data is moved to a system where it's being transformed. So the raw data might not be in a format that's suitable for querying, so the data might contain anomalies, right? That should be filtered out. So data is being ingested, from there it's being transformed, and then querying this data becomes the next step to take. So after that, data is being visualized, right? So we'll be looking at the roles and responsibilities in the world of data. So there are varieties of roles involved in managing, controlling, and using data. Some roles are business oriented, while some involve more of engineering roles. Some focus on research and some are hybrid roles that combine different aspects of data management. So we have the database administrator, we have the data engineer, we have the data analyst. So we have the data base administrator manage database, assigning permissions to users. They store backup copies of the data and restore data in case of any failure. Data engineers work with data, they apply data cleaning routines, identify business rules, and they turn data into useful information. For data analysts, they explore and analyze data to create visualizations and charts to enable organizations to make informed decisions. So what are the rules the tax data base administrator undergo daily? So they install and upgrade database servers, and application tools. They allocate system storages and manage storage requirements for database systems. They also plan storage requirements for database systems. They also involved in modifying the database structure as necessary from information given by the application developers. They also enroll users and maintain system securities. They also ensure compliance with database vendor license agreement. They are also involved in controlling and monitoring user access to the database. They monitor and optimize the performance of the database. They also help in planning backup and recovery database information. They maintain all archive data, they backup and restore databases, they contact the database vendor for technical support if there is any need for that. They also generate various reports by querying database as they need be. They also manage and monitor database replication. The data analyst tasks and responsibilities involved making large or complex data to make it they make large complex data more accessible, understandable and usable. They create charts, graphs, histogram, graphical maps and other visual models that help to explain the meaning of large volumes of data, right? They also involve in transforming, improving and integrating data from many sources depending on the business requirements. They combine data result sets across multiple sources. For example, they combine sales data, weather data, just to provide useful insight into how weather influence sales or and when it comes to certain products such as ice creams and all of that. So they find hidden patterns using data. So they deliver information in a useful and appealing way to users by creating rich graphical dashboards and reports. Data engineer tasks and responsibilities also includes developing and constructing database structures. So they also involved in maintaining and testing these database and data structures. They align the data architecture with data requirements. They are also involved in data acquisition. They develop processes for creating and retrieving information from data sets. So they use programming languages such as the SQL, the Python to examine data and also to clean or manipulate data. They also identify ways to improve data reliability, efficiency, and quality. They conduct research for industry and business questions, right? They develop sophisticated and analytical programs, machine learning, and statistical methods. They prepare data for predictive and prescriptive modeling. They use data to discover tasks that can be automated. Common database administration tools involves the SQL Server Database Administrator, um, the SQL Server Management Studio. They use that for the day-to-day database maintenance activities. They also use other systems. Other systems have their own database specific interfaces, such as the PG admin, which is for the Postgres SQL. They have the MySQL, which is for the MySQL Workbench, which is for the MySQL server. Sorry, I beg your pardon. So we also have the Azure Data Studio. So common data visualization tools used by data analysts involve the Microsoft Excel, the Microsoft Power BI, the SQL Server reporting service. So common data engineering tools they involve the SQL, the SQL Server Management Studio, the SQL command line, the Azure Databricks. They make use of the Azure HT Insights, the Azure Cosmos DB, the Hive QL, the R language, the Python language. So here are just a few knowledge texts for us to just look into, and I'll be happy if I get responses on in the comment section. So, which of the following tasks is a role of a database administrator? We just listed that in preceding slides, so you can drop your answers in the comment section. Uh, the second one, which are the following roles, is not a data job role. We have the system administrator, we have the database administrator, we have the data analyst. So I would like to have your answers in the comment section. So we have come to the end of module one. So we'll also be looking at module two in the coming lessons, and I hope that you stick around as we dive into gaining deeper knowledge as regards the world of data. I'm happy that you were able to join us, and I hope that uh, you're able to join us as we run through this series of classes for the data fundamentals, the Azure data fundamentals. So more videos will be dropping as regards these classes, and I hope you stay tuned. Thank you for joining.